Good afternoon. Well, I'm going to tell you some aspects of smart treatment with membrane bioreactors. So many of the aspects are related to the minimum space and certainly to the maximum purity that we can achieve at the same time. So most of the results were generated by one of my students, that's Sven Toys. And well, I sum up the main results of his work. So what can you expect today? So at first, I will give you a short introduction into the motivation and aims of this work that is related to a real life problem. Second thing is the design of an appropriate plant. And the third is results and conclusions that we can draw from the findings and from other activities. So this work is related to the former capital of Bonn. They have four uh, different wastewater treatment plants, and this is all of them are not according to the state of the art. All of them are quite old, and the operational management is not optimum. And so there are some things that could be changed, and this is described in several scenarios. The first scenario is to keep it as it is, 4 wastewater treatment plants. Second is to close down the smallest one and to keep the others. And what I will present is an approach that the largest one shall remain, and the others will be shut down, and the wastewater of the existing plants, they will be transferred to the remaining wastewater treatment plant. Yeah, so the problem is with this scenario that would be optimum in terms of costs and in terms of the operational management is that the space available is restricted. You can see this from the next photo here. So the a place where the wastewater treatment plant is situated is has several boundaries that cannot be changed. So that's the River Rhine. That's a highway. That's a residential area, and that's an industry area. So the place cannot be expanded. So if the scenario should work, we have to do major changes of the respective technology. So, and here membrane bioreactors come into discussion. So we when we have a look here at this rough scheme of wastewater treatment plant, you can see that the traditional way is biological treatment, clarification, filtration, and disinfection. And this could be amended with the concept of membrane bioreactors, and according to this, the required space can be reduced drastically, and at the same time, also the solids that are released by the wastewater treatment plant, they can be reduced close to zero. And another advantage is that also the COD emissions can be reduced with the help of the membrane bioreactor technology. And what is of big concern today, microplastics can be removed excellently with the help of membrane bioreactors because the membranes are a barrier, and also plastic particles are um, introduced into the biological flocks, and so it becomes easier to remove also microplastics, and this is different from the existing technology. So some research showed that fibers may be or the removal of fibers may be a little bit more difficult. But as a general application, membrane bioreactors can remove excellently microplastics. So there are some other aspects that speak for membrane bioreactor technology. So the modules are quite compact, and so it is possible to install a plant where several modules can be switched on or switched off when needed. Another advantage of membrane bioreactor technology is that we can decouple the hydraulic retention time. That's the time that the water stays in the respective plant. And the sludge age can be decoupled. So the sludge can be much older compared to conventional technology. And this leads to an adaptation of the microbiology so that a removal of several substances will be more effective compared to conventional technology. So because of this modular and small footprint that we find, it makes it possible for a retrofitting of existing treatment plants. That is especially interesting for Germany. But on the international market, certainly new plants are being built with the help of MBR technology. And what I will show you later, also, this technology is fit for many future demands concerning also uh, new appearing pollutants. So the situation concerning membrane bioreactor plants is shown here. Worldwide, we have more than 60 large-scale wastewater treatment plants with a capacity of 100,000 cubic meters per day. And the largest one is found in Singapore, and another one of this nearly the same size is in China. And also in Europe, we have a large-scale plant with 660,000 cubic meters per day in Henriksdal in Sweden. And compared to this, the existing German plants using membrane bioreactor technology are comparatively small. So this depends on the specific situation of German wastewater treatment plants and their age and the influence of the civil engineers that normally run such wastewater treatment plants. Although in this case, more process engineers are required. Well, nevertheless, we have experience in Germany, and also the idea of implementing more of these membrane bioreactors is there. So the work focused on technical feasibility, cost estimation, and on the implementation of future demands also. So when we look at the data that was required, so at first we looked at membrane area, specific footprints of the respective possible modules and references of suppliers, because this was also important for the operators of the wastewater treatment plants in Bonn. So then from this, we went to the tank area. So that means the place where such a membrane bioreactor could be placed. Also, tank depth was considered and the redundancy of existing tanks. So, and both things together helped us to have a look on the amount of modules that can be installed and compare them to the required amount of modules. We looked at the installation area and calculated the different scenarios. So with this, we come to the design of the respective plant, and my student focused on GE technology because they provided a lot of information, and it seems that this kind of seaweed module was also quite well fitting for the demands of the wastewater treatment plant in Bonn. So when you look at the existing technology, we saw that there were 4 clarifiers, and it was possible to use one clarifier line for the implementation of the membrane plant. So this is a sketch of the respective clarifiers. So 4 lines in parallel with a depth of about 4 meters. This is the footprint of a single module. The gray area shows the footprint of the original part, and the red area shows the additional area that is required for the pipings and connection lines. So we came to 2 conclusions. So it could be possible to install this respective kind of module either in variant 1 with 78 modules, or variant 2, as you can see, in a different setup with only 63 modules. And we concluded it's better to use the variant 1. This means we can install 312 modules with a area of about 515,000 square meters of area. So then we came to the respective data of the required fluxes. So the rating feed flow is about 14,000 cubic meters per hour. That amounts to the total inhabitants of this area, including also the industry, amounts to about 450,000 inhabitants, and the BOD load should be about 32,000 kilograms of BOD per kilogram of dry matter and day. So in Germany, the rating temperature is quite low. So that's the temperature that is an average over the whole year. So it's only 12 years, and this has also an influence on the respective permeate flux. The sludge age should be about 17 days, and the sludge loading should be in the range of 0.1 kilogram BOD per kilogram of dry matter and day. So this is a sketch of such a module. Well, if we installed more than 300 of these modules, then it would be possible to achieve the aim of the scenario 3 that was described, to come to only one wastewater treatment plant in the end and shut down the remaining ones. Then we had a look on the on several operating parameters. So what we could see when we changed some of the settings, that the filtration time has a large influence on the permeate flux. The relaxation time has this influence as well. Relaxation time is the time when no filtration takes place, when the membrane is left alone for a certain time, for several seconds, so that the membrane can relax and can also, in this time, also biomass can be removed by gravity from the membrane surfaces. Backflush time also has a significant influence. So that means how often and how long will be the backflush time, and how much permeate will you receive from the respective plant. So this is also a very decisive parameter. What we saw, that the backflush volume itself has not a very big influence on the net flux. So from the German Association for Water and Wastewater and Waste, there's a compilation available concerning the respective specific costs of such a membrane plant as a function of the design feed flow. You can see the design feed flow is quite small. Yeah, so this is related to the German conditions. And so from this, we could deduce the capex. That means the cost for removing the old technology and implementing a new one. So, and The operating costs were estimated based on several indicators, and from these indicators, cost functions were derived. So that in the end, we can say that the yearly total costs of this new plant would be about 7 to 10 million euros per year. And this has to be reflected with the costs of the closing down of the other existing plants, and certainly also with the newly implementation of the new implementation of the pipelines for the wastewater that are still collected in the different parts of the town and will be transported to the then only one wastewater treatment plant. So this is a short summary. So we are able to introduce membrane bioreactor technology for the treatment of the total wastewater of Bonn. This would be feasible. The estimated costs, as I said, are between 7 and 10 million euros. But this would be only a starting point. Several other costs have to be included in a more concise calculation. Well, and the most important thing is that in principle, a membrane bioreactor can also fulfill the demands of future force purification stages. So, and this is explained here. So, in the moment, neither the European laws nor the German law require the removal of PFAS and other perfluorated sulfonic acids or octanoic acid. Yes,
Hello?
yes.
5 minutes left.
Yeah, so I'm well in time. Okay, so when we look at these emerging components of concerns as pollutants, we see there is not yet the demand for wastewater treatment plants to fulfill a certain limiting value, but this is a hard discussion in the moment in Germany and in Europe. It only concerns the generation or the production of these materials. And so we have to be aware that also the wastewater treatment plants will be affected by this, these activities concerning the regulations. So first measurements were done, as is shown here on this slide. So the membrane itself can only remove about 2% of the respective PFOS substances, and the membrane bioreactor, including the membrane, can only help to remove about 60% of these materials. But if we combine the membrane bioreactor with an internal addition of powdered activated carbon, then it becomes apparent that a large-scale removal of this group of substances is possible. So about 80 to 90, 95% removal of these substances is possible. And this should be enough for the future legislative demands. Well, how could it look like? So several options for the forced treatment. So including after the membrane plant, a reaction tank for ozonation, and then granulated activated carbon as post-treatment, or granulated activated carbon addition only without any ozonation. Or the third alternative, as I said, would be to add the powdered activated carbon into the respective tank with the membrane bioreactor, and this substance is removed together with the biomass. So these options are all possible, and I think the third option would be the most interesting one in terms of costs and in terms of the footprint. So how could it look like? So this is two examples of the dosage of powdered activated carbon. So this is commercially available. That's state of the art in principle. So it could be done quite easily and could be implemented also quite easily. And you see that also the footprint is quite small. Okay, so with this, I come to the conclusion. So we calculated several scenarios using design data, using data from the supplier of the membrane modules. We did a cost estimation. We showed that it is possible to install enough membrane modules to come to a scenario where only one wastewater treatment plant in Bonn will remain. And this concept will also include a future fourth treatment step so that all future demands concerning wastewater treatment and safe wastewater treatment can be met. So with this, I've come to an end. So thank you for the attention. And if you have any questions, please feel free to ask.